This application allows employees of the City of Huntington to inventory their water infrastructures and keep track of the city's resources used to maintain a safe water system. As they go to the menu system here, they can just go ahead and hit add node, and node would be either a connection for different pipes. It could be an attachment of a pipe to another one. It could also be a pipe end. So here the node would be just of a connection at first, and let's go and type in the ID. Each node would have a unique ID number. If this number was Clado 1, we'll just type in Clado 1 for the ID number, and if you know the construction, your map, district, and so on, you can type it in. If not, we can go ahead and just enter the elevation of that node. Let's say this is the terrain elevation is 5, 6, 7, 8, 9, and as you can see, as we type in the terrain elevation, the depth given at 3 feet could also be changed to reflect the actual depth. It could be 4, 5, or whatnot. But as you change either the terrain elevation or the depth elevation, then you would see that the elevation of the actual node would be calculated using those two numbers. And once you have that, then you can go in and again select the type of node. In this case here, we want a connection node, and if you know where it's located, you can go ahead and select from the list. Again, is it sidewalk, on the easement, driveway, or whatnot. Let's say this one is on the easement. The state of the node, is it something existing, out of service, proposed, abandoned, or whatnot. Say existing, and then how you know about the placement of that node. Is it from an old map or drawing, digital map, or whatnot. You just go ahead and hit there's the condition also. If you know, you can select whatever, and you have to remember that all these drop down lists are somewhat information that you tell us to put in your table, and you can either add information to it or retract information from those tables. So we'll just go ahead and hit unknown here, and again, if you have remarks for the specific node, then you would go ahead and just type in the remarks, and as you enter the information for that node, then all you need to do is go ahead and hit enter data, and then the program would bring a cell or a block that would allow you to place exactly where that pipe connection is located. So if we say it's right here, we'll just go ahead and hit the data point, and that cell is, or that node is placed, as you can see, and showing also the annotation of that node. We'll zoom in later on to see that. With the form would come back up, allowing you to enter again a different node if you wanted to. And let's say this time we have another node is Clado 2. And let's just assume that the terrain elevation and all of that is the same. Then we'll go ahead again, we have a connection node. We can go ahead again, hit enter data, and as you can see, the same block would come back to us to place exactly where that connection is located. So click it here, hit it, and then we can now close the form. And if we had more node or more connection or pipe ends or attachment to place, we can just follow this process using this form, adding the information, and then hitting enter data and placing those elements exactly where they are located. So we'll go ahead here and close this one, and as I said, you can zoom into the element and see the information that you put into the database. This is the block or cell that represents the type of connection. As you put in the information, you see the terrain elevation and the depth also added to that specific point. Now once we have a node or system of node generated, then we can use the program here to go ahead and place pipes between those nodes by just again using add pipe. Let's go ahead and add the pipe here, and here we can go and select the from to node in the upstream downstream node. So here we can type in CL if you wanted to, or select Clado 1 as the from node, and then go to the second one and select Clado 2 as the second node. And as you can see here, as we select the first and second node, a pipe ID is given to the pipe that we're going to be drawing, and then you have again a series of drop down list which would allow people to select exactly what it is that they're trying to place on today's system, if it's a main, transport, supply, or whatnot. So here we'll go and select main. In the same way you have material here, you can select PVC, DI, or whatnot. We can go and select DI, and as we select DI, you see we're given a series of dimension that correspond to the type of material. Let's say select 12 here. But if we go back and let's say we made a mistake, that wasn't DI but we wanted PVC, we can select PVC, and when we go to the dimension, you can see that we're given again a list of dimension that would correspond to PVC type material. Again, we'll just go back here and go back to DI and then select 12. So as you change the material, you can see that the dimension would change to reflect exactly the dimension that you would have only for that specific type pipe. If you know the manufacturer of the pipe, again you can go select. If not, you can just hit either. If you know exactly whether this was from a map and the map number and so on, you can add that the flow direction is 0 or 1. As you can see here, the hint would take enter 0 if flow direction is reverse. If we leave that to 1, that means the flow is going to be from node 1 to node 2, I mean collider 1 to collider 2. And again, as you know the rest of the information like the location, the condition, the state, construction, your district, survey or whatnot, you would enter that information into your system. And if not, you just go ahead and hit the enter data. And as you hit the enter data, then the program would somewhat zoom into those two nodes and give you a line starting from the first point, and you can enter the line now just following basically the layout of that pipe. Let's say if we have a line going up here and to this pipe until the last verse is before the end node, then we can hit reset, and you would see that the program would extend that line to the receiving node and then give us some text that we can place that would annotate that pipe. We can place the text, and again a form would come up allowing us to add another pipe. Just like for the nodes, if you have more pipes to enter in your database here, you would just go in and again fill the form and then hit enter data and then go back to the map, place the pipe, and then follow the process again. Since we're just placing one pipe here, we'll go ahead and close this form here. And again, as I mentioned, you can zoom in here and see exactly the annotation for the pipe that we type in, and the dimension of the pipe. And as you place the pipe, also the program will calculate the length of that pipe. As you can see here, it's a 727 38 feet pipe, and you see the type and the material of the pipe also. Once you place your pipe, given the starting and ending node, you would have to also go and enter the elevation of the pipe, and because this is what would allow you to somewhat draw a correct profile of the pipe, because you can have a pipe maybe going under or over another pipe or whatnot, and until you enter those elevations to show exactly where the pipe is going up and down, then you would not have the correct elevation. So the program will allow you to go in here and say add elevation, and then we can add the elevation of the pipe. Let's say that we are going to be put in here an elevation of let's go 7 or 576, and then change our depth to, let's say, 4. Then as we type in the terrain elevation and put the depth at 4, then the elevation we're going to be placing is going to be an elevation of 572, and we can go ahead and here and select where we want to place that elevation on the pipe. Let's say we want to place elevation here on the pipe, and as you can see again, the program would go and place a circle to show where we place that elevation on the pipe, and also annotate it to show exactly what the elevation is on that pipe. Let's assume that we have another elevation on the pipe here, and again it's the same elevation but at just some other point of the pipe. So we'll just go ahead and hit enter data and then go to that section of the pipe that we want to use for that elevation. Let's say here, click it, accept, and then enter that elevation, and you can see again the form would come back, and if we have more elevation on the pipe, we could just go ahead and enter more of that elevation also. Now let's again assume that we have a fire hydrant or a meter line or whatnot connected to this main that we draw in, and we will go to again the program and say at first that we want to place an attachment node, which also we would need to go and hit add node. And when this time here we can give it let's say another ID number. Let's say this is Clado 3, and since we are putting an attachment on the pipe, we don't need to really give it the terrain elevation or whatnot. The program would calculate exactly what the elevation of that attachment is going to be given the elevation on the pipe and the station where that attachment is located. So let's go ahead here and hit attach as type. We can keep the rest exactly the way it is on the form and just hit enter data. And if we wanted to place that attachment right here on the pipe, then we'll go ahead and click at that junction, accept it. And if we had more attachment, we would go into the program again and fill in the form and enter the right information, hit enter data, and then go to the pipe, click it, and then we would place all those attachments where they need it. And as I was saying here, even though we did not type in the elevation information for the attachment, the program would go in and given the elevation that we have on the pipes and where this attachment is located, calculate what would be the elevation of that specific attachment. And as you can see here, it's 569.67, and this also would be proven when later on we draw the profile of the pipe. It will show exactly on the profile where this attachment is located. And let's say that we have, as I say, a fire hydrant or a line that's going to a fire hydrant. Here we would have to go again and place, let's say, another node, hit add node, and this time let's call it Clado 4, and this would be let's say a pipe end. That's to show that this is just going to somewhat to a fire hydrant. And then again here we need to enter the information because that pipe end is going to be placed exactly apart from other pipes. Let's go in and enter the elevation here. Let's say the elevation is 568, the terrain elevation, the depth is 3, and then that would give us an elevation for that pipe end of 565. Hit enter, and if you wanted that pipe end to be located at this side of the map, then we'll just go ahead and hit the enter data, and then again it would place that element exactly where we click it, and then show the information or the annotation that correspond to that that pipe end. Now that we have again the attachment and we have the pipe end, now if we want we can go into the program and then create again a pipe that would be this time our service line going to that fire hydrant. Again here we can go and select the node that we want. We type in Clado 3 if we want, and then go back to the other one and select Clado 4. You can either type it correctly or just go to the list and select also the node that you want, let's say Clado 4. And here we have a, let's say, a service line, and let's say it's PVC, and we can go to the dimension here. Let's say it's a 6-inch, and just type in 6. And just like the other forms, you know, as you know the information, or as the information is available to you, you can just go ahead and enter that information onto the form and hit enter data. And again, as we hit enter data, you would see a line coming from the first node that we selected and allowing us to place the different vertices on this pipe. If we just have this line going from one point to the other point, to the end of the pipe, then we just hit the reset, and you see the line connecting to that end of the pipe and giving us annotation that we can place also onto the text itself. You can change the angle if you want and place this text to follow some type of orientation. We just go ahead and place this, and as you see again, the form would come back up for you to place as a service line or as a main line if you so desired. So since this is the one that we wanted to place, we'll just go ahead and close this form. And then as we close the form, now we can go to our program and say that we want to place now a component, and a fire hydrant would be a component, just like a valve would be a component, and so on. And hit add component, and again a form would come up showing information that pertain to a component. And here we can go ahead and let's type in you know, CL hide 1. That would be the ID for our fire hydrant. If we have a service number, we'll go ahead and press a service number, and then we have categories of component here. It could have been a consumer, it could have been a pump, a valve, a pressure leak, fire hydrant, and so on. Here we want fire hydrant. We'll go ahead and hit fire hydrant, and as you can see, when you select a component, the form would change somewhat to show the information that only would go to that specific component. Like here, as I hit fire hydrant, you can see that we have the subtype, status, depth, and so on. If I had gone in and hit let's say valve, you can see that some more information is coming to the form, and so on. So the program will keep track of what component that you select and give you exactly the fields that you need to enter the information for that component. So let's go back and hit fire hydrant here, selecting fire hydrant, and then if we have, or if you know the subtype, can go ahead and select it, either the 2-way, 3-way. If we have a 3-way, we'll select a 3-way. Again, just like the other form, if you know the manufacturer, the location, and all of that, you would go ahead and click those. Again, here we don't need to really give it the elevation of that specific component, because we're going to be placing it on a pipe, and then the program would calculate, depending on the elevation of that pipe, what would be the right elevation for the component that we're placing in. So here we can go ahead and just hit enter data, and then we're asked to select a point on a pipe where we want to enter that fire hydrant. Let's say that the fire hydrant was just a little bit before that pipe end, and we'll select on that pipe and then accept it. And as you can see, the program would go in and place a hydrant exactly where we selected on that pipe, and bring the form again to allow us to place some more hydrants if we wanted to onto the system. Since this is the one that we wanted to place, we'll just go ahead and click on collapse this form. We have some overlapping text here. We can move some of the text if we wanted to show that, again, as I said, we did not type in the elevation of that fire hydrant, but the program would, just like we type in component or add component for fire hydrant, we could have selected also to add some, let's say, valve component or so on onto our program. Let's say we go ahead and to again the submenu here and hit add component, and this time let's say we type in valve CL as our ID, and then go to category and select, let's say, a valve. Again, we go into the form and select what we want. Let's say this is a gate valve, the box cover is exposed, and so on. We have the status of the valve, is it open, closed, repaired. We can select that, the direction of the valve, and so on. Let's say same, and so on. And again, we can go in and fill the rest of the information, but we don't need to go in and fill the terrain, elevation or whatnot, because the program would calculate, again, depending on where the valve is located, what the proper elevation would be for that item. We can go ahead here and hit enter, and if we wanted to place the valve on this section of the pipe, then we'll just go ahead and click on that section, accept it, and as you can see, the program would bring in again a cell and place it at that section of the pipe and give us the elevation of that specific valve. Let's say we wanted to place another valve exactly the same. Let's say this time it's maybe a butterfly. Hit enter data and go back to another section of the pipe. Let's say we want to place a valve on this section of the pipe here. Again, select that section, accept it, and again you would see the program would go in and place the valve and show the elevation of that valve and so on. And you can just use this form and continue placing information onto the system as they are required. We could have gone, and if we had a leak on that pipe, let's say we could go in and select leak, and again we have here, you know, a field that gives us the subtype of that leak, and we can go and select which one that we want. Let's say if it's a hole in the pipe, we'll just select hole in pipe, and again if we know the pressure or whatnot, we'll enter this information. And as we do, we can go in and hit enter data. As we can see, we cannot use the same ID for the same component for a different component. So when we do that, we'll have an error here or a message that tells us that we have already used this ID that we need to change. So we can hit OK, change this, and then go to the ID. And this time, instead of valve, call it let's say leak CL. And then this time we can go and hit enter data, and then we are asked again to go to the pipe and select a point where that leak is occurring. And then let's say we go to this section of the pipe here and say we have a leak at this side. Click OK, and then again, as you would see here, the program would go in, place that leak, annotate it, and calculate the appropriate elevation for that leak also. So we can go out here and close this form. We could have been also in a situation where we already have lines that are drawn that we want to use as construction line to basically create a water model. Let's say here this is a water line without attributes. Then we can just go into our menu system again and click on construct pipe, and then click onto the construction line, accept it, and we are asked to define the nodes that would be used for that line. If the node is a connection, then just hit OK for the first node. And we ask again to hit either OK or cancel for the second node, and we'll also use that it is a connection at the other end, and just go ahead and hit OK. And as you can see here, the program would go in and create those two nodes, the first one, and then you know, given some elevation and so on, create also the second node, again give it an ID number and elevation, and then go in and draw the pipe that would be defined by those two nodes, ND200 and ND200A. Now that we've placed those nodes using construction line, we could go into the program if we wanted to and change the node elevation. We can just go here and hit change node elevation, tag onto the node, accept it. If we want, we can go and change even the ID of this node here. Maybe we don't want to call it ND200, we just want to call it maybe CLA, let's say 650. Then we'll change that, and then here we can go and change also the terrain elevation. Maybe it's 576, and then as you can see here, the program would go and calculate the elevation for us and hit update. Then it'll go in and again change the text on that node. It's also changed in the database and show the type again, the depth, and then the actual terrain elevation of that node. Not only it'll change that node, but it'll also change anything that's connected to the node, like the pipe that we had here before, had an ID of ND 200. Now it has an ID of CL650 because it's now going from CL650 to ND200A. And at the same time, we can also go into the program and change the node ID for also this node that we just placed, and click it and accept. Again, we can go in here and say it's maybe CLA651, and again we can go here and change the terrain elevation. Let's say this time it's maybe 6565, and then hit update, and as you can see, it'll go ahead and annotate that node again, change it in the database, and show on the map that we have changed the ID of that node to CLA651, and again change the ID of the pipe itself and show it as being a pipe going from CLA650 to CLA651. The same way we go in and use a line to construct basically this pipe, we could have also had in our map some either valve or component item that have no attributes, and then use those to associate them with the pipe that we already drawn, and then have it linked to the database. Here we can just go to the menu system and again and hit associate component with pipe, and go in and tag the component that we want to associate with the pipe, accept it. A form comes up which allows us to go in and enter the ID of the component that we want. Let's say if we call this VA 2300 if we wanted to, and then go to the category and select valve, type in the type of valve. Let's say this is a gate valve, and so on. And just like the other form, you go in and fill basically all the information in, and as you're done, then just go ahead and hit enter data, and as you enter the data into the database, now you're asked to select the pipe that would be somewhat associated with this valve. We go ahead and click on that pipe, accept it, and as you can see here, our valve is now into the database, connected to that pipe, and showing the information that we just put in that form, the ID of the valve, the type of valve it is, gate, and calculating also the elevation of that component, giving the elevation that we have on the pipe, and so on. And we could again just go in here using the review attribute data and tag onto that valve, accept it, and as you can see, now we have basically a component on that graphic that before did not have any attributes and now has attribute and is connected to a certain pipe. Just go ahead and click it here and exit that form. As we enter the data into our mapping system, we are also given the opportunity to review any one of those elements and change the attributes. Let's say we go in here to the hunt water submenu and just hit review attribute data. Then you can go in and select whichever element that you want, accept it. The form would come up showing exactly the data on that specific element. And here, let's say we found that that pipe was in a poor condition. We can just go and update the condition, change it to poor, and hit update. As you can see, the program would come back and say that pipe is updated. Then we can hit OK, close it, and you can go ahead and update as many items as you want. The same way you can go in and change the attribute of some of the elements. You can also go and change the elevation or engineering data of some of those components. Let's say we had to change the elevation or pipe elevation. You can go to the menu and just hit change pipe elevation. Again, select that pipe elevation, accept it. A form comes up which allows us to go, and let's say that we found out that the depth on that pipe was not really 4 but 2 feet. Then we can go ahead and type into tab, and you see the elevation changing from 572 to 574. Then we can go ahead and just hit update. Again, the program would go in and update the database and change the elevation of that pipe. But for us to maintain integrity of the different data set that we have, we need to go back to the program and here update the elevations of all elements. This would allow the program to go back and recalculate basically the elevations of all the components that are on the pipes that have been changed. Let's say update element elevation. As you can see here, the component elevation that was 572 now has changed from 572 to 573.56 because we have changed this elevation to 574 and maintain the other elevation as being 572. And all of this would be shown as you draw the profile. It should place those elements exactly where they are supposed to be on the elevation pipes. Let's go ahead here and just go to the menu and select profile pipe. Go ahead and tag this pipe, accept it. We're asked to select a section of the map where we want this profile drawn. Zoom out a little bit, reset, and then go up here and say draw the profile at this section. As you can see here, the profile is drawn, and you can see exactly the components of those components. and if we had made mistakes on recalculating the elevations of those components, then you would see an elevation being either above or below the line, but not exactly at the correct junction and with the correct elevation also. You can see here, this is one of the valve gate we had on that pipe. We had also placed a leak on the pipe, as you can see here where it's located. And you can zoom out and look at the profile again and see what else we have on that pipe. We have an attachment showing exactly at that location of the pipe, and then we have also another valve showing here. And we could have gone in and changed those elevation, redraw the profile, and you would see exactly how those components would somewhat shift it in elevation to be located exactly where they're supposed to be on the pipe. We could also be in a situation where we have information on valve that are coming from maybe a different database or different table, and then here we can just use the program to review that information by going into, again, the submenu and hitting review valve extended data. Click on that and then go to a valve, tag that valve, accept it, and then it will bring a form that shows exactly the information that we have on that valve coming from a different table than the component table. Here you can see information showing the streets and cross street, which means the intersection where the valve is located, the size of the valve, the directions, and so on, and also information showing exactly where on those street or section of the map where the valve is located, showing the coordinate X and coordinate Y, 49 feet south of this center line drive, and then 110 feet west of that drive, and so on. You see the number of turns here for the valve, the turn date, if the valve was checked and it's okay or not, comments and whatnot, again the type, the side, the box type, and so on. And here you can again go in and add more information to that extended table, and then update the form if you want it to. Just go ahead and close this form. As we enter leaks into our mapping system, we need also to go and create work orders, which means assigning the job to certain people and making sure that the job is done in time and with probably the minimum amount of resources. So here we could go in to the menu again and just click on new work order, and you are asked to then go and select the leak that you're about to fix or assign to some employees. Go and click on that one, accept it. The program would go in and then create a form that would show exactly where the leak is located and put a circle around it to show that this is the one that we want to work on, and give you again room so you can type in what the problem is. We can go and add to the problem description if you want. You can go in and select the employees that you want to do the job. Let's say if this is going to Joe, and then we can go and hit or type in the date when this job is scheduled. Maybe let's say July 1603, the status, if it started, we can just say it's in progress. And if we have some remarks, we can go and add those remarks, and then as we enter the information, we could either go and hit save and insert that into the database. The same way we can also go hit print and print that form and put it on in file or give it to somebody. Let's just go and save this to the database, hit save, and as you would see, the program will come and say that that work order has been added to your system. Hit OK, close this, and as you create or add those work orders to your system, you want to have also the ability to go back and edit those and make sure that the job that was performed is also added to your database. So here we can go and hit edit work order, again go and tag that leak, accept it, and you can see that the same form comes back up showing the map exactly where the work order is or where the leak is located, and showing the information that we had tagged in before. Here, if the problem was fixed, we can just go ahead and add in the date it was fixed. Let's say it was fixed the same date, and go and type that, and then we can change the status if you want from in progress to completed. And if we had remarks, we can go and add remarks. Let's say here maybe we had a cost on this specific job, we can go and type in the cost, let's say $356.76, and again we can print this form and give it to somebody, or we can go and just update it into the database. And as you can see here, it will go and tell us that this order has been updated, and then we can just hit OK and close this form. This could have been also a situation where we know that there's a leak on one of the pipe, when we needed to know which valves should be turned off to allow the crewman to repair that leak. So the program here, we could just go in and click on shut off valve, and here we asked to go and select a leak, and let's just go and say select this leak here, accept it. And as you would see, then the program would go in and put circle on the valve that needs to be turned off, and highlight those valves, and at the same time here show on this form that the numbers that needs to be turned off are, let's say here NDV 200 and CL AV2002, and then you can either print this or just tell the crew members exactly which valve they need to turn off to fix that specific problem. And as you're done, you can just go ahead and click OK, and then dismiss that window. Employees can also use this program to find valves in one of two ways, either by going to here the submenu and just hitting find valve. Then again, you're given here a drop down list where you can go in and click in and select the valve that you want to find. Let's say NDV200, click it and then hit find valve, and the program will just shift to where the valve is located, show it, and highlight that valve. In the same way, you could have also just used the program and do a scanning, which would scan the map for all the valves that it contains, and then give you a list of those valves and the ID number, the size, where they're located, and so on. And here again, you can go to the list and just see whichever valve you want to find and just click on that valve. Let's say we wanted to find 002-004. You do is click that one, and you can see the map shifting to that valve, and then putting it in the middle of your screen so you can find it's highlighted and so on. And if you want to find another valve, you could just go in and select another one, and as you can see, the map would just shift to that valve and so on.